Hi everyone, this is Huaishao Luo. It's my pleasure to introduce our recent work, MaP, a matrix-based prediction approach to improve spec extraction in machine reading comprehension. Let's start from the problem. Spec extraction is one of the essential tasks. Given the passage and the question, the task is to extract a span amount of plausible text from the corresponding passage as the candidate answer. This is an example of this task. September 1976 is what we need to locate in the passage. Such a problem has been studied extensively in the past decade. A usual definition is to predict the start index S and end index E given passage P and question Q. We can divide the previous work into two approaches. One is the independent approach, and the other is the conditional approach. The difference between them is whether considering the relationship between start and indexes when modeling. Specifically, the independent approach is regarding the generation of start index and end index independently. The conditional approach constructs a dependent route from start index when predicting the end index. It means when generating the end probability vector, the model will utilize the presentation of start index. Nevertheless, both start and end probability are vectors. To cover many more probability, we extend the probability vector to a probability matrix. It's a natural manner because, as shown in the animation, every start position has an end probability vector. Such a matrix contains start and end index pairs. Simultaneously, each probability can be regarded as a value coming from a joint probability distribution of start and end pairs. However, there are high computational costs and memory issues if the input sequence is long. As an instance, the matrix contains 600,000 probability values if the sequence length is 500. To solve this problem, we adopt a sampling-based training strategy to train the model at each iteration by choosing top k probability from the matrix. We gave a sample to demonstrate such a training process. At each iteration, we sample top k like 5, including the ground truth position to train the model. The probability in ground truth position goes up and the sample top 4 positions goes down. Then we repeat the process of sampling and optimization. Such a sampling-based training approach has the same goal with the training on the whole probabilities, thus should have approximate results. We feather Ensemble start to end and end to start directions to improve the robust and performance. The target start-end pair is from the F set and B set with a probability of PS multiplied PE and PE multiplied PS. To train the matrix-based model, there are 4 steps. The difference with previous work is how to generate NOR gates or probabilities. The optimizer is cross-entropy. We evaluate our strategy on 4 datasets, including scored 1.1, news QA, hot pop QA, and natural questions. BERT and BIDF are used as our backbones. Specifically, we borrow them when body expect the top layer to implement the proposed strategy to finish the spec extraction on different datasets. Our strategy achieves a consistent improvement compared with the independent approach and the vector-based conditional approach. As we can observe, the MaP was section out of section in both BERT-based and BERT-large groups. It proves that the ensemble of both directions is helpful for our task. The MaP-F was 12 out of 12 in EM, and 8 out of 12 in F1 demonstrate that the matrix-based conditional approach is capable of predicting a clear answer span that matches human judgment exactly. We analyze our strategies in two aspects. The left finger shows that MaP works better than the vector-based conditional approach as a span decreases. Since should answer have a high rate in all answer spans, so the matrix-based conditional approach is better for the answer span task. The right finger demonstrates the convergence of sampling strategy. It indeed will cost longer training steps to get the same noise compared with standard training process. The conclusion has three aspects. The first is we introduce a matrix-based conditional approach to extract answer span. Then, a sampling-based training strategy is utilized to address the training process on MaP. Further, an ensemble method on two directions is used to improve the performance. Thank you.